Express the following rational expressions in simplest form. State the non-permissible values of the rational expression as restrictions on the variable. So in A, we have x minus 1 over 1 minus x. So what we want to do here is we want to be able to cancel the numerator and the denominator, the two binomials, against each other. But the way it's written here, they're not actually equivalent, or it doesn't appear that they're equivalent. So what we're going to do here is, in the numerator, we're simply going to switch the terms around. So it's going to say negative 1 plus x over 1 minus x. And now in the numerator, we factor out a negative 1. So it's simply going to be negative times positive 1 minus x. And now we can see that we can cancel those two binomials. And we're left with just negative 1. In terms of the restrictions, the non-permissible values here, there's only one, and it's going to be 1, because if x equals to 1, if we plug it in here, 1 minus 1 is 0, which is not permitted. In B, we have 5x plus 15 over 2x plus 6. Let's start by factoring the numerator and the denominator. In the numerator, the greatest common factor is 5, which leaves us with x plus 3. In the denominator, we can factor out 2, which leaves us with x plus 3 as well. The two binomials, x plus 3, they cancel. And we're left with 5 over 2. And the non-permissible values here are going to be, well, we have to go back all the way to the beginning here. And if we look at the denominator here, we are looking for a value of x which would turn this denominator equal to 0, which is not permitted. So what we can do here is we can pull out the denominator, 2x plus 6. We equal it to 0, and then we solve for x. If we solve this expression for x, so we subtract 6 from both sides, divide by 2, we're going to get x equals negative 6 over 2, which is the same thing as negative 3. So the non-permissible value here is going to be negative 3. In C, now we have 8y squared minus 4y divided by 4y minus 2. Again, we're going to factor out the greatest common factor in the numerator and the denominator. In the numerator, the GCF is 4y, leaving us with 2y minus 1. In the denominator, we can factor out a 2, leaving us with 2y minus 1. This allows us to cancel these two binomials, leaving us with 4y over 2. 4 divided by 2 is just 2, so we're left with 2y. And then we need to identify the non-permissible values. So again, we go back to the beginning here, and we pull out this denominator, and we equal it to 0. And then we solve for y. So we add 2 to both sides, divide by 4. So y equals 2 over 4, which can be reduced down to 1 over 2. So the restriction here is going to be that x cannot equal to 1 over 2. In D, we have x squared minus 2x 2 minus x. In the numerator, we can factor out an x, leaving us with x minus 2. And the denominator stays the same. Now, if we take a look at the binomial that we have in the numerator and the binomial that we have in the denominator, this scenario here is the same scenario we had in A, right here. So we now know that this can be rewritten as follows. In the numerator, we can factor out a -1 and switch the terms around. So that's going to end up being -x times +2 minus x divided by 2 minus x. And now we can see that we can cancel these two binomials. We're left with -x, and then we are going to have restrictions. And if we look at denominator over here, we can see that x cannot equal to +2. Okay. Let's move on to E and F. So in E we have 15x minus 5x cubed over 3x squared minus x to the power of 4. So we're going to proceed here by factoring out the GCF in the numerator and the denominator. In the numerator, the greatest common factor is going to be 5x, leaving us with 3 minus x squared. In the denominator, we can factor out x squared, leaving us with 3 minus x squared as well. So now we see that we can cancel the 3 minus x squared in the numerator and the denominator, as well as the x in the numerator and one of the x's in the denominator. So this is going to leave us with 5 over x. And the restriction here is going to be that x cannot equal to 0. And then what we have to do here, we have to be careful. So clearly the restriction that x cannot equal to 0, that comes from here. But then we have to go back and look through our work. If we take a look over here, we can see that x squared, so again, it's going to be the same thing. So here, x cannot equal to 0. But then we multiply that by this binomial. And there will be another restriction right here. So what we're going to do is we're going to take that binomial, we're going to pull it out, and we're going to go 3 minus x squared equals to 0. And we're going to solve it for x. So we subtract 3 from both sides, which leaves us with negative x squared equals negative 3. We multiply both sides by -1 to get rid of the minus sign in front of the x squared. So that gives us x squared equals +3. And then to get x, we would take the square root of both sides. So x equals square root of 3. So x cannot equal to square root of 3, because if it does, this binomial here would equal to 0, which it is not permitted to do. So we would say that our second non-permissible value here, our second restriction, is going to be that x cannot equal to square root of 3. Right? And then final one. F is 10x minus 5x squared over 3x squared minus 6x. So we proceed the same way. We factor out the greatest common factor in the numerator and the denominator. In the numerator, that is 5x, leaving us with 2 minus x. In the denominator, the greatest common factor is going to be 3x, leaving us with x minus 2. So again, we have this situation here where we will have to factor out a -1 in one of these binomials and flip the order of those terms. So if we do it in the numerator, we end up with a -1 as part of the GCF. We flip the order of those terms, so it's going to be positive x minus 2. And now we're able to cancel these two binomials. We can also cancel these two x's. which leaves us with negative 5/3. And then we have some restrictions. There are no restrictions on the final answer. If we look over here, well, x cannot equal to 0, so that's going to be one restriction. And then we have x minus 2, so in this scenario here, x cannot equal positive 2. Okay, and there are no further restrictions.